Let's talk about where function is not differentiable. That means that derivative of the function does not exist. Derivative of the function does not exist. The function is not continuous, so at the holes, gaps, vertical asymptotes. Let me remind you how it looks like. For the function, hole is excluded point, so for example like this, or like that. Here is excluded point. Gaps, gap is when you jump up or jump down, like this. At this point you have a gap. Vertical asymptotes, let me draw vertical asymptote for you, for example like this. Function cannot cross vertical asymptote. Sharp corners, how sharp corners looks like? It's like absolute value function, regular or upside down. Here derivative does not exist, here derivative does not exist. Also it could be curvy, so right here derivative does not exist and right here derivative does not exist. Why derivative does not exist for the sharp shapes? Derivative is the slope of the tangent line. Right here the slope will be positive, right here slope will be negative. And what we have altogether at this point, we do not know. So limit from the left will be not the same as limit from the right. We have the same situation for every sharp corner. Next one. I'm telling you that derivative does not exist when we have vertical tangent line, and we will talk about that a little later. I just want to explain you how it looks like on the picture. It is possible that the function somewhere looks like this. And at this point, if you draw tangent line, it will be vertical. Derivative is slope of the tangent line, which is slope of the vertical line does not exist. That's why. Now I give you example. This is my function f of x. It has a lot of interesting things, like vertical asymptote here, gap at 1, hole at 2, then it has sharp shape at 4, and it has hole again at 5. The only regular points that I give you here, 3 at 3 function is the smooth curve, and at 6 function is the smooth curve. So let's mention all of them: holes, gaps, vertical asymptote, sharp corners, for the points where derivative does not exist. Derivative does not exist at -1 because this is the vertical asymptote. Derivative does not exist at +1 because you have gap here. Derivative does not exist at 2 because it is excluded point. And derivative does not exist also at 4 because it is sharp. And derivative does not exist at 5 because again we have excluded points. That's how to analyze the given graph when you need to find points where derivative does not exist. Find holes, gaps, vertical asymptotes, sharp shapes. A little later you will probably have examples with the vertical tangent, but not at this point, so this is enough now.